Hello guys, welcome to my channel. This is another video on the triple integration in which we are going to discuss few problems related to volume integrals, and we are going to understand about cylindrical polar coordinate system and as well as spherical polar coordinate system. In this video, we are going to also explore about how to find the center of mass concept using the volume integral, and we are going to see much more complicated problems in the triple integration. So this is the minute of cap. Let's get started. So first of all, I'm going to take one of the important problem in which it says that set up an integral integration for evaluating the triple integral of some function. Suppose there is given that there is some function f of x, y, z over tetrahedron. There is a tetrahedron in the three-dimensional space. Consider we have here x, y, and z. So there is a function which is enclosed by some tetrahedron with whose region is, let us say, D, and whose vertices are at 0 0. So these are the coordinates of vertices of this tetrahedron: 1 comma 1 comma 0. Another one is 0 1 comma 0, and next one is 0 comma 1 comma 1. Use the order of integration means that you have to define the volume integral of this particular function in this region, which is denoted by dx, dy, and dz, dy, and dx. So first of all, let us just annotate where is these points will be. For an example, first one is that orbit at the origin. Another one is at x, y, and 0. So this is x, this is y, and this is z. So when z is equal to 0, this will lie on the xy plane. So we can say that from here, let us say this is 1, and this is over here 1. So this point should be just like at the cross section of 1. Okay. So this one is done. Now 0 1 comma 0, when x is equal to 0, y is 1 and 0. Okay, so this is also y1 is equal to 0. So 1 is already done. And another one is that when x is 0, y and z which is 1. So therefore it is like z is equal to 1. So this is maybe over here at z is equal to 1. Sorry about it. So here I can say that this is y comma z. I can just take like this 0 comma 1 0, which is over here, and I can again pull back like this one. Okay, so you can now you can see over the tetrahedron just like that because this one is, I'm going to connect over here to this one is already connected, this one is like this. So this is the shape of the tetrahedron. Okay, so this is kind of a shape of tetrahedron. Now you have to find the volume integration of this function which is at this one. So how we can find the function which is this is a tetrahedron. So first of all, the concept says that what you're required to do, you have to take a shadow of this z, means that you have to find the shadow of this on xy plane. So xy plane is bounded by this one, which is, let us say, y is equal to x. Correct. So this is some kind of a triangular type of structure over here, which is just like it. So what you have to do is that first you need to find this dz, and I'm just writing over here x, y, and z. This is the function. I need to find the limits. First, I'm going to take the limits in dz, and this dz can be found out by tracing the line like this. So first of all, this is cutting over here, means that at xy plane when z is equal to 0, and this one is when this is a surface. Okay, this is kind of a surface. So when it is leaving this particular portion, so you understand that this line is denoted by y is equal to x. On the other hand, this line is showing you y is equal to z. So, but the thing is that we are talking about this OA and B. So this OAB is a triangular kind of plane which is in the z axis. So how we can find out that this triangular kind of plane, what will be the, so first of all, z is leaving from 0 because we are going to take an integration from here. But we already know that this integral will be in terms of x and y. Okay, understood? So this is like that you are tracing a plane which is going in the z direction whose base is y is equal to x. So I can just write that, okay, this is the plane which is lying on the z. So z will become y minus of x. So you can see that will this equation satisfy when y is equal to 0, x is equal to 0? it's still 0. When y is equal to 1, x is equal to 1, z is still 1, because this is showing me the point A. That's why I have chosen A and B. So from this we can say that this is the equation that can satisfy the above limit. So I can say that this portion is at y minus x, which is z is equal to y minus x. Now another equation is for dy. So how we can find out the dy? So this dy is going from how it will go. So we can see that one of the line has to be parallel with dy. So when we are tracing the equation with dy, we have to take a parallel line, which is now again cutting from this line at y is equal to x and leaving, and by cutting this one at y is equal to 1. So I can say that this is going from left to right. So this will be y is equal to x and y is equal to 1. So this is the another limit. On the other hand, when you have found everything, then what you can do is that you can take a line which is parallel to x-axis, and you can see that it is cutting at x is equal to 0 to this one. So this line is just only coming from this to this. So the x will be 0 to 1. So this x will be when your z and y is done. So this is the limit that where x is varying. So the x is varying from 0 to simply 1. So this is the extremist limit that you don't have to worry about it. So this is how we can find the volume of any function which is in the region of this tetrahedron. So this is one of the example. Now we can evaluate the another example by using the same technique. So for an example, if fxyz is considered to be it is 1, so you can easily find out the integral just like that. You can just say that dz would be this one z, and from 0 to y minus x. Over here dy, and sorry, this would be dx. So this is dx. So this will go from y minus x. This is done already. This will go from x to 1. Come on, x to 1, and this is 0 to 1. So you can just plug it that y minus x and 0. So I will get y minus x into dy, and in this I'm gonna consider x to be a constant. So the limit will go from x to 1, 0 to 1. Then over here I can simply write it that dy will becomes y square by 2 minus x into y, again putting the limit between x to 1, and then dx, and everything would be 0 to 1. So from here I can say that y square by 2 minus xy, just I have to put first of all this one. So the upper limit would be half minus x, then negative of again x square by 2 minus x square. So this x square minus x square by 2, which becomes minus x square by 2. So this is minus x square by 2, and dx. Everything is fine. Yes. So now I am going to do one more integral like 0 to 1. This is become x by 2 minus x square by 2 minus plus x cube by 6. And the integral is done. I'm going to put limit from 0 to 1. And after putting the limit of 0 to 1, you can see that this is half minus half plus 1 by 6. And everything would be 0. So this is negative of 0. So this is coming out to be 1 by 6. So if there is a function f of x, y, z whose is 1, and so what is the volume of the tetrahedron inside this one, inside this region 0, 1 and 1. So this is the volume of this tetrahedron. So using the volume integral, any complicated region can be, simply you can find out the volume by using this technique. Okay. So that's why this is, very important one to understand it. Now I'm going to take one more problem so that you can, be too much habituate with this volume integral. So the question is that find the volume of the region that is D encloses by the surfaces z is equal to x squared plus 3y squared and z is equal to 8 minus x squared minus y squared. So you have to find the volume which is enclosed by only this z1. One of the volume, or one of the region or surface is given by this one, and another surface is given by this one. So when you are trying to find out the volume, okay, using the volume integral, so visualizing these, surfaces is kind of, very complicated one, that okay, how we can find it. So but if you are just, you know that what is the sphere, what is the, cylinder kind of structure is, that we can just write here that x square plus y square plus z is equal to 8. Okay, and over here I can just write that x square plus 3y square is equal to z. So you can see that this is not a cylindrical equation, correct? So this is more bit of like, what you can say, it is like, a cylindrical type of, characteristic, that some of it, shows the cylinder, shows the circle, and the circle is something, it is evolving with some, linearly, correct? So the shape will become like more like conic type of shape. But the problem is that there are two surfaces. So how we can find out the volume? Because in total we have to find the volume. So first of all we need to find out what is the limits in dz as well as dy and dx, correct? So but the problem is that, okay, what could be the intersection region, or what could be the, which one is the bigger region, and how we can find it. So that is a very important issue over here, that how we can find out the limits. Okay, suppose over here x, y and z, and here x square plus y square plus z is equal to 8. So you may see that if you put x square y square is equal to 0, then z becomes over here 8. On the other hand, if you put over here x square y square is equal to 0, that means z is equal to 0. It says that this region, this surface will somehow, will be always, some of the portion will always be in the xy plane. On the other hand, when you are seeing this particular region, x square y square is equal to 0, 0, then z is equal to 8. So this would be in upper region. So when you are trying to evaluate the limit by going from downwards to upward, you already know that this will be in the lower and this would be in the upper limit. So I can say that, okay, there will be some dz, and here I can just say that, okay, this would be like from z is equal to, I can write 8 minus, sorry, this would be higher, x square plus 3y square from 8 minus x square minus y square. So this is dz limit. Understood? Now what about another one? Let us say dy. So you see that I have not made any kind of, structure. I am just using that which one is lying in xy plane and which one is lying in z plane. So that is the simple way. Now the problem is that how we can find the limit in dy. Now in order to find the limit in dy, it means that, these two surfaces, they may intersect. And how can they intersect? Because they have the same z. So I can say that, okay, 8 minus x square minus y square has to be equal to x square plus 3y square. So when they are be equal, then some of the portion will intersect to each other. When this intersect, then I can find out the what is the y. So I can say here that 8 is equal to 2x square plus 4y square. So I can just find out that, okay, 4y, so dividing by everything, dividing by 2, so I will get 4, and hence I can write it over here that y square is equal to 4 minus x square, sorry, by 2, correct? So y becomes plus minus 4 minus x square by 2. So this is how we can, find out that, okay, the dy is expanding from plus minus to y. So I can simply write that, okay, because I have to go from here to here, and this is the minus and plus. So I can just write here that square root of 4 minus x square by 2 to plus 4 minus x square by 2. Now what about x? I have already told you that x will be some, number. So I can say that, okay, this is look like x square plus 2y square is equal to 4. So I can just write x square by 4 plus 2y square by 4 is equal to 1, which is basically y square by 2. So this is like an ellipse equation, isn't it? So this is the elliptical equation. Okay. So you have already, simplified, you have already write y in terms of x, because y is one of the parameter is depending on x, and another parameter will be independent. So here we have taken x as independent. So you can see that x will vary from minus 2 to plus 2. Understood? Because x will be, because this is the a, x square by a square plus y square by b square. So x is equal to plus minus a. So this is the, the point at which the ellipse will cut each other. So we can just say that, okay, the x equation will be dx would be minus 2 to plus 2. So after evaluating this one, this will be the total volume of the region bounded by these two surfaces, z is equal to x square plus 3y square and z is equal to 8 minus x square minus y square. So this is the whole concept of doing this type of problems. So you don't have to worry about too much things that how we can solve this type of problems, or this may look very complicated, but in the sense they are not too much complicated. Now I'm going to talk about the masses and their moments. Okay. So first of all, what is the mass and the moment? So this is the concept of center of mass. I think you have already explored this one in physics. So center of mass. You see that if you have any masses distributed over any kind of surface, we can see that, okay, the center of that geometry would be the center of mass. On the other hand, if you have any arbitrary kind of shape, to find out the to locate the center of mass is kind of very challenging, because some portion would be x, y, and also z. So you have to always trace in that what's going on in both direction, and then you have to average it, and then you can find out that, okay, this could be the center of mass. Okay, so in order to find the center of mass, you have to first find that what could be the masses. So mass of any arbitrary object can be find out by just make some volumetric type of thing. Maybe it is cuboid or maybe cube. So in order to find the mass, what you can do, you can just say that, okay, I'm gonna sum is differential masses which is made up of this which will make eventually which will make the whole mass, and I am dividing this mass in both dx, dy, and dz. So in some sense, it is a cuboid of a differential lengths dx, dy, and dz. So okay, fine. You can just sum each and every k is equal to 0 to infinity, and then you can easily find out what could be the limits. Okay, but the problem is that how we can do it? We can do it by using the concept of volume. So I can say that, okay, because the density which may be dependent on these x, y, z, I can just write density could be delta xk, yk, and zk, and I'm just writing that whatever the volume of this particular cuboid. So once we have, because this is very differential, so I can say that each and every bit is a continuous, because we cannot add, we cannot just, it is not a discrete type. We cannot just count it. What you can do is that we can do the following, because this integral is going from 0 to infinity. I can convert everything in terms of delta, which will depend on x, y, z, and then dv. So here it says that whatever the density which is depend on the locations of that particular point times the volume. But here we can say that, okay, everything is continuous. So I can just say that this energy density is also continuous in particular volume, and then it is dV. So once you know that volume or density, how the density is varying over this particular volume, you can just integrate, and you will easily find out the thing. Now the problem is that now one more important definition. So here, by using this, you can find the total mass of any arbitrary system. Now one of the concept that comes is that you have to first find out the mass moment. Okay, in order to find the center of mass, you have to first define mass moment. Pardon my handwriting. So mass moment. So if you have any mass distribution along any plane, because when we are talking about the 3D, we are always talking about some kind of plane. Let us say this is an XY plane. So moment would be always perpendicular to that plane. So suppose I want to find out the mass moment along the in the XY axis, or so it will be the mass moment would be in the Z. So suppose that if I want to find out the mass moment in X direction, it means that it's happening in Y and Z direction. So in some sense, mass moment along the x-axis would be mass of yz. So mass of yz would be triple integral x times delta of xyz times dv. So this will give you the mass moment along the x-axis. And in order to find the center of mass, we can say that, okay, this could be the center of mass, which is x bar. And I can just find out center of mass by using mass moment along the x-axis, which is in yz plane, are divided by the total mass of that arbitrary body. So when you are defining this one, you can easily find out this is the case. Similarly, y bar would be m. Now since we are talking about in this direction, so we have to take about this plane, so xz over total mass. And similarly, I want to find the z bar. So z bar in this direction. So this will be xy. So xy over m is going to give you, these are the center of mass coordinate of any particular. Now, if there is, it's a volume kind of distribution. Suppose that this is something called surface area. So in surface area, the dimensionality gets reduced. So we have, instead of z, we have just only x and y. So we can say that, okay, whatever the there it is, I can just write the mass moment in, let us say, in y direction. So y is basically perpendicular to x. I can just write here that double integral over here x delta x comma y and the dA. So how the surface is, distributed over this kind of plane. Okay, so this will give you the mass moment in two-dimensional plate. Understood. So similarly, I can just define here mx would be y delta of x comma y and dA. And I already have told you that this x bar would be, now over here, this is my of m, and y bar is mx over m. So you have to, first define. So it is a system in which we are talking about symmetry. Okay, it's the cylinder polar coordinate system. We have already come across this cylinder, and the cylinder is the pile of circles. So if you have a lot of pile of circles with constant radius, then you will get the cylinder. So in some sense, cylinder has, if I'm making an coordinate axis like this, for an example, this is the coordinate axis. So I can say that in xy plane, there is a symmetry of circle, and on the other hand, in z plane, it will simply increases. So how we can find out? So we can say that, okay, what we can do is that we can take two things. For an example, over here, because the cylinder is 3-dimension, we can say that, okay, I am choosing the two things because the volume can be find out first by doing dz, okay, and then dy, and then dx. This will ultimately give you. Now, since dy and x, the volume is in the dy and dx. So when you trace the volume, what you will get, because this will have some kind of thickness, because there is a dz and there is dy and dx. So you have to make that, okay, there is a one point of z1 and there will be another point of z2. So it is like this. Okay, so this is like this. So when you are doing it, the graph is very bad. Okay, so you may see that for any particular angle, that is, let us say the theta and so on. So you have, for an example, I am making this one. So let us say for at particular angle d theta, you have this one r, and this dr, we have some particular delta r, because this is a solid and this is a solid. The whole thing is solid, 3-dimensional. So each and everywhere you have a variation. So what is the arc length? This arc length would be r d theta. And this is in the 2-dimension, this is making and some kind of rectangle. So we already understand that this length is delta r and this is r d theta. So what is the area? The area would be delta r times r d theta. So now this area is in xy plane. So I can say just write that dx and dy is basically this delta r can become dr and this will become r d theta. Understood? And now once you are doing the integration in dz, this dz is what? Dz is just taking the limit at how the height is increasing. It means that it is going from z1 to z2. Understood? So in a very complicated scenario, the z is depending on yx. In some sense, we can say that because we have transformed everything dx dy into dr d theta, I can simplify the whole above integral just like that. That you have the volume is written as dz, which may be the depending on, let us say, g1 r comma theta, g2 r comma theta, and then I'm going to introduce over here that this might be, okay, this will be like r dr. So you have to just find the integral in the radially, because how this radially is changing. So I can just simply say that, okay, this could be like h1. Now this will depending on theta, h2 of theta, and then I'm going to do the integral d theta. So this would be become, let us say, theta 1 to theta, whatever the theta. So first of all, we have to evaluate that what is the shadow, or how the region is varying along the z-axis. Secondly, how the change is taking place along the radial direction. And then third one is that how we are, it is rotating, because of how the orientation is changed. So as the orientation will change, you will form a kind of, symmetric or the circular or maybe the elliptical region. So how we can find the volume of, sorry, cylinder? So you see that in dz is, just increasing from 0 to some h. So I can say that, okay, dz is not depending on anything. It is a, very symmetric object. So everything is independent, and everything is z, r, theta are perpendicular to each other, because you see that this r and theta, which is varying in xy plane, they are perpendicular to each other, just like x and y. And similarly, z is mutually perpendicular to each these things. So z, r, and theta, they are orthogonal to each other. So dz can be written as, okay, 0 to h. Now, what about RDR? RDR is again the cylinder. The RDR is the disk, or you may say that it is a circle. So RDR, and it will become 0 to, let us say, capital R. And on the other hand, when we are talking about d theta will go from 0 to, because the theta is going in full circle. So it will start from over here, let us say 0, and then it will go up to here, and it will making a 2 pi on the center. So it's going from 0 to 2 pi. So this is how we are going to take everything. So first of all, I'm going to do the integral like this. Dz would be h minus 0 is h, and then r square by 2. So I can just write here r square by 2, and then theta would become 2 pi minus 0 is 2 pi. 2 becomes cancelled. So this is pi r square h. So this is the very simplest way to evaluate the volume of cylinder using the cylindrical coordinate system. So in cylindrical coordinate system, what are the variables? The variables are r, theta, which is simply the polar coordinate system r and theta, and then there is the one variable which is z. And there is a length element, we can write it. Let's suppose that something is in cylindrical, and how we can locate, how we can measure the distance between the 2 points on the cylinder. Okay, and this is a very important point from the physical perspective. You can just write here that dr square plus r square d theta square plus dz square. So whenever we're writing volume, so this is giving you some particular length, because this is ds square. So I can just write here dr into r d theta into dz, and this is giving you volume. On the other hand, if you want to find the area along z direction, because in the area is a vector quantity. So if you are moving, let us say you have x and y plane, consider this is x and y plane. So if x is going to y, so it means that you have a vector, means that you are rotating x and y like this. So suppose anything is attached with this, or maybe you can say that it is a right hand rule. So when you will curl your fingers like this, it will go in the upward direction. So over here we can say that, okay, it's in z direction. Okay, so if you want to find out the area along the z axis, we can say that, okay, I'm going to take this dr and d theta, dr and r d theta, and it will give you the area in z axis. Now similarly, you may choose to go from y to z, z to x, and so on, z to r, and so you can have any combination, and it will give you the area along that direction. Understood? So this is the concept of cylindrical system. On the other hand, I'm going to introduce you very specifically what is the spherical polar coordinate system. Spherical polar system. Now, in the spherical polar system, you have the again sphere, and it is a very, and again the symmetric one. So this is x, and again is y and z. So one thing is, make sure that, okay, you are having in this over here, and then the z is varying like this. But over here, you can say that in the cylinder, you have, two kind of things. One thing is that there is a circle, because when you're trying to, see the sphere, you see that you can make these circles, but these circles have the varying radius. Unlike the cylinder case, where when the cylinder is made up of the piles of circles and the radius is fixed, over here the radius is not fixed. You may see that it is going from 0 to 2 pi, 0 to 2 pi. But the problem is that as you are going upward in the z direction or going downward, the radius of these circles are varying. So that's why, in order to incorporate these things, we have to introduce two different variables. And these variables are that, first of all, I'm going to measure from here, from z to here, is the theta, and from x I'm going to introduce two things. It will be phi. So now these are the very important technicalities that we have to understand. Okay, so for an example, the v dv is equal to dx dy and dz. So first of all, we have to see that how the things will vary. So the z is going from here. So z will be, this one will go from 0 to pi. This is the radius of the sphere. So this radius is going from 0 to something radius. So when you are plotting this, taking the differential element, you will find that this will make some kind of surface over here. Okay, so in order to find the surface, you have to do a lot of things. So I'm not going in more detail. What you can easily find out that you can just so first of all, you have to find out that what's happening in x, z and y plane and what's going on in x and y plane. Understood? So when you are done, you can say that the volume can be find out in the spherical polarity system as like r square dr and then sine theta d theta and d phi. Okay, so d phi is in the plane when you are adding all the circles, which is going from 0 to 2 pi. So I can just simply say that, okay, everything will go to 0 to 2 pi because the last integral is d phi. On the other hand, when you are talking about sine theta, so this angle is varying from this positive z to negative z. So it's going from 0 to pi. So this will go for 0 to pi. On the other hand, the r will go from 0 to, let us say, capital. So when you have the spherical polar condensed system and you want to try to evaluate everything, so if anything is spherically symmetric, then you have to just do this one, this r dr, r square dr, sine theta d theta and d phi. So r square dr will give you r cube over 3. Sine theta d theta will give you minus of cos theta, and it will go from 0 to pi. And d phi is going from 0 to 2 pi. So this is really phi and 0 to 2 pi. So this is r cube by 3 minus cos theta. So minus is taking common. Cos pi minus cos 0. Cos pi is negative of 1 minus 1. Minus 1 and minus plus. And 2. And this will become 2 pi. So this is minus plus 2. 4 pi r cube over 3. 4 by 3 pi r cube. So this is the volume of the sphere. So what is the length element for this spherical system? ds square is equal to, first of all, dr square and then r square d theta and then r square sine square d phi. We will see in the next video that how we can derive these things. And so the volume element will be, the volume element is dr and then r d theta and then r sine theta d phi. So that's how you can get this r square dr and d theta sine theta and d phi. And if you want to find the area along any direction, let us say if you want to find the area along z direction, you can say that, okay, r d theta dr in the z direction. So you are just adding these circles. On the other hand, if you want to find any direction, so you can just add this one. Let us say we want to find this r direction, we can just multiply these two things. I can simply say that, okay, this is r d theta times r sine theta and you go d phi. So suppose I want to find the area of the sphere. I know that the r is constant, so this dr will become 0. Understood? So you have r constant. So I can simply say that, okay, I'm going to integral this dA while this r is constant, r square will be constant, and then d theta sine theta, this d theta will go from 0 to pi and d phi will go for 0 to 2 pi. So once you have this thing, I can just write here 2 pi r square and this will give you just only 2. This is 4 pi r square. So this is how we can find the area of a sphere and the volume of the sphere. In the next video, we are going to look at the details that how we can evaluate, how we can say that this dx is simply like it, y is that like it, and so on. And we will going to deal with more important problems based on it. And with this, I think we will we know how to do all these problems, and we will look at very definite problems, and then we are going to deal with the Jacobians. So if you like my video, please subscribe and share to your friends. This is Aminado Cap. See you later.